This week on Foresight Radio, driverless cars, digital twins in the industrial Internet of Things, with best-selling author and industry pundit Joe Barkai. I'm your host, Tom Kalopoulos, and Foresight Radio is brought to you by Wasabi Technologies. Find out more about Wasabi at wasabi.com. Joe, one of the things that we hear a lot about lately is the Internet of Things, but you focus more specifically on the industrial Internet of Things. Talk a bit about that and how that differs from what we call the IoT, the Internet of Things.
So fundamentally, they're not different. Fundamentally, we talk about pieces of assets or pieces of information sources that provide more information you can aggregate, you can analyze, you can draw conclusions. The reason why I want to preface this with industry is because A, it's in the industrial setting, that is usually pieces of capital equipment or cars or medical equipment and so on, but also to focus there on the outcome. You know, I always want to know about who cares, why is this important, why is the IoT important, and to whom and how. And it's easier to explain those, to create these outcome-based scenarios in industrial settings. But this is not to say there's no value to, personal Internet of Things.
It all creates data, obviously. The industrial Internet of Things involves much more data created by machines that's consumed by machines. So give us an example of an IIoT that maybe helps to better understand what the industrial Internet of Things is and how it works and how it creates value.
So one of the examples that I really like, and actually the book I wrote on IoT opens with that. So the use case is the Renfe high-speed rail in Spain. If you buy a ticket to ride on the train between Malaga, Barcelona, and Madrid, you actually buy a contract from Renfe, the national train system, that provides you with a guarantee of on-time arrival. If the train does not arrive within 15 minutes of the designated time, you get all your money back. So,
wow.
It's a very, very significant contract. No wonder everybody wants to take the train. Now, when you think about it, you say, well, this is a losing proposition. Trains are always late. 15 minutes, all trains, certainly here in Boston.
How would we make money in the U.S.
Exactly.
with that kind of a model?
I just came here by train, and it was only 5 or 7 minutes late. So what they did, what Renfe, the Spanish rail system did, is they contract Siemens, the provider of the train and the maintainer of the cars and the tracks. They created a contract with them to maintain the trail and provide availability. So this is a classic paradigm of IoT. You have two contracts, one between Renfe and the passengers, the other one between Renfe and Siemens. Each contract is phrased very, very differently. They phrase in terms of different outcomes. One is on-time arrival, the other one is uptime. Yet the two contracts have to work together to provide the value, to provide the outcome. And this really ties to the other observation, which is really to get value from industrial IoT data, we have to consider the human element. Many organizations are totally myopic about the products. When the product leaves the door, it gets installed, sold, whatever they lose sight of the product. They don't know how it operates. They don't know what outcome it provides. They don't know how the users interact with it. And when they do know, it's usually bad news, warranty claim, complaints, and so on. So the IoT provides opportunity to understand the machine, but also the users. Often when users of equipment run into a problem, they don't usually call the 800 number first time because they don't want to be talked down at, they don't want to be offended, they don't want to be put on hold, etc. It's surprising how often they go to the internet to look for advice. And it's very, very strange how they get advice from strangers. They download patches from total foreigners they never met before, but they trust them more than they try the support. But in the process of doing that, they don't miss an opportunity, of course, to give advice. The product sucks, the service is no good, I don't like the company. So this information is also out there as information source for the organization to make better decisions. It's really now humans become sensors.
The industrial Internet of Things is much more expansive than just machines talking to other machines, in other words.
Absolutely. And I think that if a company is thinking about an IoT strategy and all they care about is instrumenting and connecting assets, they're missing a huge piece. What about the users? What about the environment? What about these instruments talk to another instrument? It's really a more complex ecosystem that we never had an opportunity to look into. Now we do.
So your book, The Outcome Economy, talks about two very important things that I want to touch on here. The first is that we now have the ability to sense our customers in a way we never could before. So in the past, we would do a focus group, and the focus group would tell us what we wanted to hear in many cases. Today, if I have a Tesla, that Tesla is communicating enormous amounts of information about my behavior back to Tesla. So you have an ability to know me at a level that was incomprehensible just 5 or 10 years ago. And the second is, what that then does, again, getting back to the point of your book, it creates an outcome-driven business model where I will pay you based on the performance, the degree to which you are actually able to do what I anticipate or expect that you can do through that product or service. So could you talk a bit about that shift from the focus group to sort of a sensor-based customer service, customer support model, and then talk a bit more about the outcome economy and what that is and how that works?
We still do a lot of focus groups, and we try to kind of get an understanding of the market and the customers. But in reality, these are very, very difficult to do because it's very hard to get the right sample of people. They tend to be long and expensive efforts. And more importantly, even if you wanted to do that, from the time you conducted the focus group until you actually use the data and release the product, in the case of a car, it could be 5 years. In 5 years, customers have changed, competition has changed, new technology arrived, and you don't see it. I often argue that the whole notion of the innovation funnel, if implemented kind of as prescribed, and most companies do that, is really wrong. It's really false or flawed, I should say, because you lose connection with what's happening out there. So now you have the ability, using this Tesla example, to have an ongoing focus group. It's really the best ever focus group you can get because customer tastes changed, whether it's because technology, because of competition, because they just aged. And, a young person buys a Tesla, now he has a family, very different approach. And this gives you the ability to be continuously with your hand on the pulse.
It's a real-time focus group in some way. A focus group of one in real time.
But at the same time, you look at the data from all of them. So you actually have a better focus group because now you can segregate it much more precisely by age, by geography, by demographic, by weather pattern, by location.
So where's that being done? Tesla is the example that comes to mind because it is one of the most connected cars today. Are there other examples of where that's being done today?
Automakers are doing it, but they do it very sporadically, and it's too dependent upon initiative of an individual or product line. It is not still propagated to become kind of a mindset, a culture. We don't have a culture of IoT. We have technology and we have users. We don't have a culture of IoT.
So let's come back to how that changes the business model and how culture plays a role in that. But I first want to talk about the outcome economy. It's a wonderful term. I love it. However, it creates a lot of risk for a provider of a service or a product because now you're on the hook, as in your railway example, of delivering a service within a certain very strict set of parameters. How many folks are actually doing that? How many providers of services are doing that?
I think it's getting more and more common, but it's true that usually there are large industrial organizations, conglomerates. It's not common small products and small companies. I think it will change. It has to change because you can no longer compete on price alone. It's getting harder and harder to compete on features and functions, especially if you're looking at advanced economies versus offshoring and low-cost manufacturing. You really need to provide better, more comprehensive service. So it's really moving from products and features and functions to, and you said it yourself earlier, it's the outcome. What is the value that the product provides and to whom? Also, once you start looking at kind of this as an whole ecosystem, your product becomes a platform. So Renfe could potentially put more services on top of their IoT platform. So you become now an orchestrator of services, not only provider of seats in a car.
The example in the aviation industry that I've heard you talk about is for jet aircraft is our engines and what's called time on wing, the actual time that engine is in service, which brings up an interesting question. Who finally owns the engine and how do you charge for the service of the engine? Do you charge for it by the air mile, by the hour, as opposed to buying the engine outright or leasing it?
Well, you charge by airtime, or lift power. So what was the availability? What was the uptime? So typically the Rolls-Royce or GE or Pratt will own the engine. It's not very dissimilar from leasing, but you measure the performance based on uptime.
You talk a lot about this term digital twin, which I'm fascinated by. Well, define it for us. What is a digital twin? What's the easiest way to understand what a digital twin is?
The easiest way to look at the digital twin is a digital model or replica of a physical product. So, for example, we talk about a car. So the digital twin would be the 3D model and all the other pieces of information that describe and represent the car. Now, why is this important? Other than it's very, very cool, because you can look at stuff in real time and you can... The ability then now to have better insight as far as the performance. You can understand and simulate behaviors. You can test different scenarios and say, what if? And you don't really need to be there. The car example perhaps is too complex, but look at wind turbine, which is slightly simpler. If you have a model of the wind turbine running back digitally in the back office, you can then really observe behavior. You can understand the impact of different changes in the field and draw conclusions. You can again simulate. You can test the impact of changes on the digital model and then move it down to the field. But saying that is not enough, because to me the digital twin is not yet another model. So it's not like there's a 3D model of the turbine and then there's a manufacturing bill of material, and maybe there's service. To me, it's really the ability to follow the life cycle of the turbine from cradle to grave and continuously evolve the digital model. So I want the model to evolve and change through this IoT. I want the model to, for example, respond to wear and tear, the natural wear and tear of the equipment. I want it to be more sensitive to weather conditions, so you throw in simulation on top of the 3D model. I think that many conversations on the digital twin are missing it. I hear too many people talk about digital twin, and you can substitute twin for model, digital model, 3D CAD model, simulation model. No, this is missing the point. The point is I want this to replicate the entire life cycle of the equipment.
The volumes of data required for what Joe is calling a digital twin are difficult for us to fully understand and appreciate today. One example I often use is that of an autonomous vehicle. AVs today, even Waymo's autonomous driverless car, for example, will capture about 11 terabytes each day. Typically, you can count on an AV to capture somewhere between 2 and 20 terabytes to be fully autonomous. It's going to be closer to the high end of that range. But let's take the 2 terabytes to be conservative. Multiply that out by 365 days. You get about 7.3 petabytes of information generated yearly by just one autonomous vehicle. What that means in today's terms is that it would cost about $300,000 to $400,000 to store all that data in the cloud. So your Tesla Model 3, which goes for $30,000 to $40,000, now suddenly requires 10 times as much investment to store the data. So you can see how today digital twins may make a lot of sense in terms of how we demonstrate their capability, but to scale digital twins in the way that will be required for industrial applications creates an entirely new set of issues and challenges from the standpoint of where all that data will be stored. Well, we have metaphors that we're accustomed to using. When you talk about digital twin, the first thing that pops into my mind is a simulator. But as you say, there's so much more than simulation, because a simulator is built once and then it's done. It doesn't evolve with the actual physical object that it's simulating. And that comes back to this issue of culture. Culture often ends up being the thing that most delays technological adoption. What are the cultural impediments when we talk about things like an outcome-based economy, when we look at the industrial Internet of Things? Because all these make perfect sense. They save money, they allow us to do all these build these wonderful new business models. What's standing in the way of that culturally?
What's standing in the way is really the need to change everything we do. We have to change the entire way of thinking, the entire way of we approach product development. We need to first front load our decisions. We need to be able to look at entire product lifecycle early in the process. We need to build features and behaviors and maybe even architecture that reflects the new business model. One of the most commonly used examples of IoT is for service. So we connect a piece of equipment to a remote asset. The asset alerts us there's a problem because we know what it is, because we have the digital twin. We know the exact configuration. We can even figure out maybe the part, etc., etc. But there's more to it, because if I really want to improve my uptime contract, you asked earlier about how do you make money out of this. I want my contract to be optimized to my needs. So if I guarantee uptime, I want to know that I can reach it. So therefore, in the case of service, I want to optimize my service delivery. To optimize service delivery, the design, the architecture of the product should probably be larger field replaceable parts, because each part represents many failures. It's just pull it out, pull it back in, and I'm done. That makes sense from an uptime perspective. It makes little sense from an inventory perspective. It perhaps makes little sense because now I need 2 technicians to remove a large part. So now we have a set of constraints whose solutions contradict each other, they alter with each other. So the whole idea of designing for IoT is really considering all these downstream activities. And organizations are really not built to do that. Very often, service requirements show up only late in the design. I remember many years ago when I had a real job, and this was actually working with a large heavy equipment manufacturer. At some point, we started looking at the serviceability aspects of the equipment, and we said, no, we need some changes. And product management goes, no, you can't do that. Design is frozen. We have no more RAM. These were the days where RAM was scarce commodity. So it's too late. So now you release a product that perhaps meets all the functional requirements, but does not meet downstream activity requirements such as service. It requires the entire organization to change and think differently. It requires functions that tend to be triggered later in the process to be brought forward. It requires us to invest upfront in order to reap the benefits down the road. It's so foreign.
Yeah, I often talk about the fact that we're moving out of an industrial era model / paradigm. The way we think about the problem and the potential solutions and the opportunities is tethered to that industrial era model. So we're building the IIoT around an old model, and the reality is the model itself has to change, but that means the way we think about the model has to change as well.
Exactly. I mean, we're talking about a situation where you have a digital twin that can mimic future activities, that can mimic behaviors. So we can really optimize decisions short term, but also long term. But the organization is not as flexible as a digital twin. It has a set of very rigid rules, and they don't tend to change. Granted, some areas are not as easy to change because perhaps compliance and risk. Yeah, I understand that. But we have to start this journey. We cannot just wait until this happens. And companies that will take it sooner, I think, will be the winners because they'll have greater flexibility, greater agility, they'll understand behaviors sooner, and they'll respond faster and better.
Part of the answer is that you need to start experimenting with this, even if you don't know exactly where you're going to apply it, just to build the competency and the knowledge base to be able to make those decisions later on. Yeah,
that's a great point, and I think that this is really amplified by the fact that many features and functions are now implemented in software, which means changes are very quickly. Can be made very quickly. You mentioned Tesla. Tesla is known for updating functionality using software updates over the air. They are not the first one to do that. I mean, people think that Tesla were the first ones. No, they were not. But they were the first ones that showed the value of doing that and to bite the bullet as it were and really go ahead and offer this flexibility. So now you have the ability to detect issues sooner, to issue fixes sooner, and instead of calling the car to the dealership, just issue it as a patch over the air. So we have the mechanisms. So once again, it's not the technology, it's the culture that needs to change.
You're listening to Foresight Radio, and we're taking a quick break to thank our sponsor of this episode, Wasabi Technologies, the leader in the next generation of cloud storage. Find out more about Wasabi at wasabi.com.
Thinking about moving your data storage to the cloud? Wasabi is enterprise-class cloud storage at 1/5 the price of Amazon S3 and up to 6 times faster, with no fees for egress or API requests. Wasabi's low-cost, high-speed, fully secure storage blows away the competition, including Google and Microsoft. Disruption starts here. Do the math for yourself and start a free trial at wasabi.com.
Well, a natural segue to what you're just talking about was the topic of autonomous vehicles, or AVs. And I love this topic because the reality is none of us know what that world's going to look like when vehicles are fully autonomous. What I do know is that today we hold the AV technology to a much higher standard than we do the human being. But there's also a supply chain that's threatened. It's not just me as a driver that's threatened. The supply chain, the dealers are threatened. And all of that threat is going to translate into obstacles to adopting AVs, despite the enormous benefits ecologically, from a safety standpoint, from a logistics standpoint, that we could achieve. What are your thoughts on AVs and the direction they're going in, and what do you see as sort of the evolution of that marketplace?
There's no doubt that AVs provide huge opportunities, both for passengers and perhaps even more so to e-commerce and logistics and so on. Adoption is slow because I think that we, like you said, we hold cars to the higher standards, and perhaps we're not quite willing to change our behavior and our lifestyle. I think it's a matter of time before we kind of are convinced that it has value. I do think that perhaps we're going the wrong way about showing the value. I think we're overemphasizing the risks and so on. The way perhaps some of these car makers are going about proving the value perhaps is wrong. I mean, the Silicon Valley culture of let's try it and break it and see what happens, it's probably not the right mechanism when we're dealing with cars and human lives and so on.
Do you think that's because of the risk factor and the potential incidents where cars wouldn't be involved with a human being?
Yes, fatalities and damage, but also there's a little bit of kind of we can do it type attitude, which I think is rubs some people the wrong way. I believe that the way to do it is really to kind of find better managed applications. The example that I always use in this context is, so you go to the airport and you want to rent a car, unless you take an Uber, and you wait for this bus to take you to your car. So here comes large, noisy, polluting bus, and you and two other people on the bus, and they take you to your destination. 2 minutes later, another bus from another rental company. It's wasteful. It's really, really ridiculous. What we ought to have is autonomous cars in a semi-protected environment, so semi-dedicated lanes. The route is well mapped. The chances of interruptions or surprises are very, very small. So you have an app that summons this pod, takes you to the car rental place. So we need to find those well-managed special applications. Think about factory campuses, universities, hospitals, ports. This is the way to, A, fix the technology, B, as importantly, lower the cost of some of these technologies, especially in AVs, and develop trust on the part of the public. So that, I think, is something we're moving this direction, but I think we're not doing enough. The other part, which I think goes back to your question about the value, I think there's greater value in commercial applications, not for passenger cars. When it comes to passenger cars, it's really not about you and I, because we may like to drive, and it's really about the elderly, people with disabilities. Those are the people who will benefit. But for that, we need to get much higher level of cars and behavior. I'd like to see more autonomous trucks, for example. And they don't have to be fully autonomous. How about a platoon of trucks? The lead trucks is either autonomous or semi-autonomous, or even not, even kind of driven by a driver. But the following trucks should really be autonomous. Again, it's okay to have a driver as a backup, but she or he don't have to drive, so they're not tired. So the whole thing becomes so much more efficient and well managed, not to mention the fact that you save on fuel, because if the trucks follow each other very closely, they benefit from reduced drag. I think that we are going, again, it's too much of a Silicon Valley mentality. Oh, we can fix it, we'll put it out there, and don't worry about it. I disagree.
There's a lot of high value, very specific narrow areas where we can apply the technology, in other words, where we can see benefit with relatively low risk. However, here's one thing that I think about, and I'd love to get your opinion on this. When I consider the applications of autonomous vehicles, and I think about where globally they could have the greatest impact, we might very well see autonomous vehicles get greater traction, pardon the pun, outside of the U.S., because there's so many interests in the U.S. that will prevent that. For example, trucking and unions. There's been an enormous amount of discussion around this point regarding autonomous vehicles and where they're most likely to get, pardon the pun, traction in terms of their adoption. The fact is that there are a lot of regulatory hurdles and labor hurdles in the U.S. that might very well create a momentary pause or a lapse in our ability to keep up with the rest of the world when it comes to AVs. Delphi Group did a research report last year in 2018 that looked at the future of transportation in the year 2050. And one of the conclusions in the report, which was co-authored with Idea Farms, an Indian consultancy, identified the opportunities outside of the U.S. as being the more probable early adopters, because you have a landscape there that is not as rigorously governed by transportation regulation, and a need which from an economic standpoint could present incredible opportunity to create efficiencies in otherwise relatively dysfunctional transportation systems. It's an interesting thought, and one way in which the U.S. may very well quickly lose ground if we don't identify ways in which to make AVs a more viable alternative, especially in commercial applications such as trucking. There are developing countries in the world that can easily leapfrog us, where they don't have those obstacles, in the same way that former Soviet countries that are Eastern Bloc countries leapfrogged us with telecommunications. The same thing could happen with autonomous vehicles. Do you think that's a real threat? Is that a genuine concern?
I think it's possible, especially because they can create this kind of an easier on-ramp, pardon the pun.
This is an area ripe for puns.
Yeah, I know, and most of them are going to be terrible. But they can, for example, we cannot, in the U.S., cannot have dedicated lane to autonomous vehicles. I'd love to see that, because one of the things I dread the most is between now and the fact that in the time we have many autonomous cars. I dread the time where we have smart cars and stupid drivers on the road, sharing the road.
Well, and that's my concern as well. I think we will have to go through. I don't see how we avoid that. So we will have an era. How long it will be, we'll have to wait and see, I guess, when there will be smart cars, and we can call them stupid or even normal drivers who don't drive so well, both sharing the road. That's an fascinating thing to observe,
right,
and consider.
I don't know if it helps at all, but I think that the time for that is a little bit further out. The average age of cars, passenger cars in the U.S. is about 12 years, and they get older because baby boomers no longer buy as many cars. Cars are very reliable. There's no need for new cars. So let's kind of take a number. Let's say 30% of the cars, when 30% of the cars are smart and safe, we'll start seeing the impact in terms of reduced fatalities, lower congestion, and so on. The rate in which we refresh the fleet shows that it will take about 10 years to get to 30% penetration from the time cars are so capable. So it's a little bit out there. But back to our other geographies example, I think they can build highways with dedicated lanes. They can guard those lanes to allow autonomous vehicles to really be so much more effective. And not only passenger cars, again, autonomous public transit. I'd like to see more public transit on the roads. Taking a segue a little bit, I also want to see better coordination among the different modalities. Today, the different modalities, even within the bus system, they are not coordinated. And one more time, it's not about you and me, because we can figure it out. We can Uber if we need to, and so on. I'm thinking about the person, it's usually a woman, that needs to leave home at 4 a.m. to reach, a domestic type job. She often takes one bus that arrives exactly 2 minutes after the previous bus had left. This is wasteful. Running buses on fixed route, fixed schedule is wasteful. I want to see it in a time where these different buses are coordinated. They don't go to places where there's nobody waiting. They wait for this person who just arrived on the other bus to make the whole thing more efficient, less wasteful.
The term that I've heard used recently is the IOV, the Internet of Vehicles. In fact, what we have is the Internet of everything, but we want to categorize each of these to be able to talk about them in more specific and parochial terms. So the Internet of Vehicles, explain that one to me a little bit. It sounds as though all vehicles should be talking to each other, but the reality is there are many cars that will not be able to talk to any other vehicle for quite some time because they simply don't have the capacity, and I can't see us retrofitting that capacity or mandating it into every vehicle. So what is the IOV? Is that just the Internet of Vehicles among autonomous vehicles? Or does Tesla have one IOV and GM have another IOV?
The reality is that each car company has its own IOV. So I don't use the term. I think I don't see the value in saying it, and I think it's misleading, and I think it's pointing the wrong direction. We talked earlier about the Internet of Things, how we create ecosystems of content service providers that come together. IoT is about platforms that allow you to onboard and offboard these services and content. So I don't want to see IOVs. I want to see Internet of Everything, even though it's a bit of a cliche term, because I want to see cars talking to each other, but also talking to the public transit, talking to the infrastructure, talking to smart, helping smart city manage traffic, connect to smart road signals, and so on. It's got to be, everything has to be connected. Everything and everyone, because you are connected, I'm pointing in my Fitbit. So we're all connected. We need to benefit from the fact that everything and everybody is connected, which of course links to the other question. So what happens to privacy?
Well, so let's get into that issue of privacy, because one of the things that we're doing, no matter which Internet of we're talking about, is giving out more data about ourselves, about where we are, what we're doing, our behaviors in the moment. I saw a study that was just released by J.D. Power a few days ago that said 75% of all consumers who have connected homes, smart homes with Nest thermostats and what have you, would be willing to share that information with their insurance company if they could get a better rate. So what that says to me is, on the one hand, we say we're concerned about privacy, but on the other, we will willingly give it away if we can save a few dollars. Explain the dichotomy of that to me. Where are we going? Is privacy, has it left the station? Is that something that we shouldn't be worried about anymore? Where should we be vigilant if we should?
I think it's all about, value. Am I willing to give some privacy, knowing my information will not be abused, and do I get value from it? How do I trust the entity I give the data to use the data properly? I think that it's a very open question, and every time there's a failure, there's a breach, there are concerns. But again, we have to, as a society and also in terms of policies, and maybe this is the role for government, is to help us understand this, to create transparency, to be able to manage to some extent. I'm certainly not for government managing our lives, but this is one instance where perhaps it is the role of government to provide the policy and the guidelines. And by the way, it ties back to the question of AVs. Who is liable for an AV making the wrong decision and causing damage? AI is very difficult to understand today. Some algorithms are totally unexplainable, so no one knows how they reach a decision. And the only way to move forward without risking too much is to really have an open conversation. We have to have an open discourse. We have to have transparency of algorithms. And this is, again, perhaps where we need government to do that, because perhaps we cannot trust individual providers.
I often use the example of GPS and how Ronald Reagan decided to take the military GPS, which up until 1983 was only used by the military, and open it up. And the reason was Korean Airlines 007, which didn't have GPS and couldn't tell whether it was in Soviet airspace or not at the time. Today, none of us could imagine in the developed world being without a GPS in our pocket, in our purse. It's a necessity. At the same time, we're giving up a lot of data by using Google Maps or whatever GPS you happen to be using. But I don't think anyone questions privacy in that case because it is such an essential part of modern life. Is that the direction we're going in? Does this technology become so essential that we simply don't question the privacy piece of it anymore?
I think so. I think that parts of it, yes, will become kind of open and in public domain, as it were. And the example of GPS is a really good one because if you think about ways where our driving is helping others, also creates chaos in neighborhoods that used to be quiet.
People, like every technology, we game it. People are gaming GPS, and those in the neighborhood who don't want traffic to go through the neighborhood are gaming ways by providing their inputs. Police departments are doing the same thing. Right. So it's an interesting new battlefield. It's an arms race of sorts. And I see more of that happening, right?
Right, yes. And so again, we have to kind of have a conversation. We cannot ignore it. We have to have a conversation and to drive for transparency. Obviously, there's the whole side of, what if the bad guys are using the same technology? So you can always use this for nefarious reasons, and I don't have the answer to it. It's probably true for any technology that we can think of, all the way from, going back so many years to maybe the best example is the atomic bomb. So we made huge progress in nuclear research for a certain reason that hopefully we'll never use ever again. But it really moved nuclear physics and tools and understanding much, much faster than otherwise.
I know you spent a lot of time internationally traveling and talking about these topics to international audiences, and you have a unique perspective as a result because you're talking to people who are actually using the IIoT, that are applying it directly. What do you see as the global differences that are both going to give an advantage to certain countries or regions of the world, and maybe those cultural differences that might hold back certain regions?
I don't know if I have a good answer to that. I don't know. Do you have a clue? Can I buy a vowel?
Can you buy a vowel? I don't. So so the big questions are: is China somehow going to be able to do this better because they can mandate it? So the facial recognition stuff that they're using right now has been getting a lot of press. Not that we like that. In democratic countries, we see that as an infringement of our, an unwelcome infringement of our privacy. But certain regimes that are able to do that do have a bit of an advantage as a result.
So yes, I often get asked about Silicon Valley versus Europe versus China, or in Europe I hear envy because Silicon Valley and now in some areas other parts of the US are so active in developing, and there's kind of free market and a lot of VC funding available and so on. So they envy this free-spirited view of Silicon Valley, as it were. But at the same time, this mode of operation means tremendous waste. People developing stupid applications, people kind of focusing on the wrong things, people wasting money. You compare and contrast this with what's happening in the European Commission, where the European Commission has policies and they guide funding and they guide even universal syllabi to support those. So they're better funding, but of course it doesn't have this free innovation and enthusiasm of Silicon Valley. Which one is better? They're both good. They have their pros and cons. Very often it's about optimization of the two. We have to keep the Silicon Valley open mind, but at the same time, try to prevent silly implementation and business models that don't hold water. So that's kind of one comparison, if you will, between Europe and the US. When it comes to a country like China, it's interesting because one thing that does happen there is once the government makes a decision, everybody follows. Now, it can be the wrong decision. But now, the little that I know about the Chinese government, I do go there often, but it's hard to really get a complete picture of everything. I think some of the initiatives are very interesting. They're really putting a lot of emphasis on electric vehicles because in their mind, finally, this is a way to curb the pollution. So absolutely development of electric cars, absolutely autonomous cars. And what you know that once it gets there, everybody's going to follow. So that can leapfrog a lot of the innovation that comes from Europe and the US. At the same time, the world is kind of much more open than before, which is why you see more auto companies going to China, primarily because it's a huge net consumption market, so nobody wants to miss that opportunity.
You've seen this industry evolve for quite some time now. What has surprised you most in terms of the evolution of the Internet of Things, the industrial Internet of Things, the way it's being applied?
I think we're still in the middle, so I don't know if I have the perspective, but every so often I look back and say it seems to have developed very, very quickly. Some other innovation seems to have taken a long time, especially when we said, here's innovation, we want to change the culture. Things are happening very, very fast. So fast that sometimes what I hear in terms of use cases and examples are kind of silly. They don't really hold enough water. I still see something that has been characteristic of the industry since I started working. There is often a myopic view on the part of vendors. They don't really understand the business they're selling into. Not that they don't understand the technology, they don't understand the culture, they don't understand the mindset of the adopting community. Therefore, they create products that are really not as useful or utilitarian. They create products that it's hard for the users to accept. And now that we want technology to change the mindset, we want technology to change the culture, the barrier is even higher. And I so often sit in vendor presentations and I see the audience, when this is the audience that I know because I work in this industry, and the audience either says or at least thinks, you don't really understand my world. You don't understand my troubles. You don't understand my difficulties. You have a romantic view of my life, but this is not my life.
We romanticize technology. It's what we do. We've done it for many, many decades. And it's good to have a perspective that brings us back to the core issues, the cultural issues, the human issues. Joe, thank you so very much for joining us for Foresight Radio.
Very welcome. Thanks for having me.
That was Joe Barkai talking about the industrial Internet of Things. To find out more about Joe, just check out the links on the Foresight Radio homepage at foresightradio.com. Thanks again to our sponsors for this episode of Foresight Radio, Wasabi. Take a look at how Wasabi is changing the rules of the game for cloud storage at wasabi.com. And thank you for listening. If you enjoyed the podcast, please be sure to subscribe to Foresight Radio and to share it with your friends and colleagues. This is Tom Kalopoulos. I look forward to joining you again soon for another episode of Foresight Radio, where we explore the future of how we will live, work, and play in the 21st century.